See, generally what happens is this is your main server, which is usually running on EC2 instance or anything like that. Let's say there's a really expensive operation running on your server, all right, which consumes a lot of CPU, or which is basically kind of a secondary operation, or which you know that you can move to another service. So what you usually do is either move it to a new EC2 instance. In general, for non-critical operations, we tend to use serverless, or on AWS it's called Lambda, right? So what happens over here is there are two ways to invoke this Lambda. One is you directly invoke it using what? Oh, wait a second, man. One is directly invoke using AWS API. Another one is, let's say you want a queue mechanism to be implemented also, right? You basically keep on pushing requests into your queue, and those every single request is processed by this serverless. So what serverless usually does is it creates a new instance for every single request, right? That's why it is pay as you go function, right? What happens in that case generally is you have an API gateway. Cool. This is connected to a queue. Let's say it's SQS in this case, AWS SQS. It's kind of an ecosystem thing, right? Like we tend to use the ecosystem things because it's easier to collaborate with. So what happens is this pushes into this basically tends to let's say trigger a lambda function, a different lambda function, which pushes into this SQS. What this API gateway provides you is a simple or what do you say, endpoint. You basically hit that endpoint with an HTTP call, with an API call, with your body, required body. It is passed on to this lambda, then it pushes into it this SQS. Now you can also proceed directly by pushing into this SQS or by directly triggering this, invoking this lambda. There can be multiple approaches to that. This is what I feel is a good approach for me because, in general, because you have a proper API gateway mechanism, right? So you can add multiple checks, like let's say what all requests you wanna allow, basically course policies you can attach, and many more things like that. All right. Now this SQS is connected to this lambda. What it does is on every event that gets pushed to this SQS, this lambda is invoked. So let's say this SQS has this SQS is somewhat like this. Cool. यहाँ पे you have 1, 2, 3, 4, and so on. What will happen is for every single event, this new lambda will be invoked. So it will process the request. So you're not directly invoking the lambda. What I feel like is this is a bad way to do it. A big cross over here. This is not the correct way according to me. And this is what is the preferred way. Reason being, you can add multiple course policies in your API gateways. You can restrict IPs. You can do multiple things. So API gateway is a proper approach to follow, I guess. So this is what a normal microservice would look like. Now coming to, let's say you wanna let's say delay your DB operations, right? You wanna decrease the read and write ratio. In that instance, again, your message queues or message brokers like Kafka is a message broker, right? Those come into play. You basically keep on pushing it into a Kafka thing, and then that Kafka basically processes. There are two things in Kafka, right? One is producer and another is consumer. Basically, it keeps on producing to a particular topic, right? Yeah. It keeps on pushing. The producer keeps on pushing into a topic, and the consumer a single consumer of every single service. Let's say there's a notification service, there's a DB service. Every single consumer can consume events from that topic, and they can proceed as they want. If you want to know about basic jargons, I guess I have it over here in my Obsidian. Yeah, these are the basic jargons for Kafka. So yeah, that is how basically microservices work or interact with each other.